The method that I taught you to simplify radicals, where you factor all the way down to the prime factors and then look for doubles, works, and it'll work every time. But there's a way that is shorter. So for example, I can look at this and simplify it in my head right away, because there's a shorter way. The thing is that this shorter way, it requires like a pretty high level of knowing your multiplication tables, and just knowing, like, for example, that 80 is 16 times 5, right? So like that's not super common knowledge, but if you can see that and pull it out, there's a shorter way to do this. So here's how it works. You look at a number and see if you can figure out which perfect square is a factor. So these are the perfect squares for 9, right? Like 1 is also a perfect square, but I didn't include it because we don't care about it. There's bigger perfect squares than this, but they're not relevant to us. Like, we're not going to really use them here. So these are the perfect squares I'm looking for. So what I'm looking is, are any of these a factor of this number? And I will tell you, for all of these questions, one of these is a factor. So 4 is a factor of 80. It's true, and you could absolutely factor out 4. Okay. The thing is that what you're looking for is the biggest one. And 4 and 16 are the ones that are super tricky, because anything that has a factor of 16 also does have a factor of 4, but you really want to look for that biggest factor. Let me show you why. If I know that 80 is the same as 16 times 5, right? So see what I did there? I said, okay, I'm going to basically factor this, and 80 is 16 times 5. So I factored it into the square root of 16 and the square root of 5. Now look, what's the square root of 16? Well, the square root of 16 is 4. So this is 4 root 5, and I'm done. Okay, so it's shorter, but only if you catch this, right? Now, like, let's say I had pulled out the 4, then I would have gotten 2 root 20. The problem is that 2 root 20 is equal to this, but it's not all the way simplified, because you can actually still pull out another 4 out of 20. Okay, let's look at this one. Which of these is a factor of 75? So you might catch, like, oh, 25, right? Like, if I had 3/4, I would have 75 cents. So 75 is the same as the square root of 25 times the square root of 3. And what's the square root of 25? Well, the square root of 25 is 5. So I get 5 root 3, and it's done. Okay, so it's this first step that a lot of you are like, oh, there's no way I can do that. And it's true. So sometimes you might get to one where you're like, I'm just going to factor it, right? So like, let's say I look at one and I'm just like, I have no idea. So then that's okay. You just factor it and you do it the other way, the way that you already know how. But sometimes you might catch, like, for example, 300 would be a pain to factor. It would take a long time. But if you catch, like, oh, 300, that's 100 times 3. And what's the square root of 100, right? So what I'm looking for is, see if I can factor out one of these. Because one of these, look, square root of 100, it's 10. Done. Okay, so here's what I'm telling you. All of these problems can be done this way. But if you're like, I have no idea, that's fine. Just factor it the way you normally would, and you'll still get the same answer. This is just shorter if you can do it, right? And you might find that some you can, and some you're just like, you just brain fart and you can't. But you're looking for, right? Like here I found, oh, the factor was 16. Here I found, oh, 25 is a factor. Here I found 100 was a factor, okay? So try them.